My name is Schwemmer and I work as a senior scientist at Fraunhofer IISB. I have worked in the fields of optics and nanotechnology for more than 10 years. Currently, my focus is on various aspects of lithography, ranging from EUV to two-photon polymerization used for additive manufacturing. In the Fabulous project, I can build on knowledge, for example, in optics or statistical physics, that I acquired at different research institutes I worked before I joined Fraunhofer. I find this combination of knowledge from different fields both very interesting and highly motivating. Additionally, I can learn new things and also expand my network. I have been fascinated by optics and optical technologies since I was a student of physics. It was mainly the laser and the wide range of applications that it enables that sparked my interest. Just imagine that you can measure displacements that are only a fraction of the diameter of an atom with a laser, or that you can wield thick sheets of metal with a laser, or lasers are essential for fiber communications. Yeah, the laser is really the Swiss knife of modern technology. And of course, it plays a crucial role for the Fabulous project. The central problem to be solved is two-sided. On the one side, additional manufacturing of 3D structures shall be pushed to the next level, and on the other side, novel designs for metasurfaces are to be envisioned and analyzed to replace conventional optics by meter optics that are lighter, more compact, and have better performance. The key objectives of my research were to better understand the role of diffusion in the polymerization process and the modeling of metasurfaces. As a result, both the manufacturing and the design of metasurfaces can be optimized, or in other words, we are addressing two main promises of the Fabulous project. The most exciting insight to me was that it is possible to link reaction rates to diffusion constants in our models. Even in case the relation is more complicated than what we actually modeled, it nonetheless allowed us to develop a model that is both fast and accurate. I think it will advance the field in two ways. Obviously, our results show that what can be done, both from a modeling or theoretical perspective, what can then actually be produced. But furthermore, I hope that it will also inspire other researchers and help the whole ecosystem to flourish. Yes, I collaborated with several other researchers within the Fabulous project, and what I liked most was, apart from discussing our research, was to get to know them personally. For me, that was the most rewarding learning. The most rewarding part of my research was collaborating with so many bright minds, sharing and discussing my ideas with them, and of course learning from them. I think there are two main lessons that I learned during my research career so far. The one is that research is a collaborative effort, meaning you have to do it together. You can only do it in exchange with others. And the other learning was that sometimes, not to say always, it takes longer than expected until one obtains good results. And here I quote a former manager I had, and he used to say that it always takes longer by a factor of pi. And if you're a good researcher, it takes longer. It only takes longer by a factor of e. We are currently discussing how we can transfer and apply some of the knowledge on metasurfaces to other applications, for example, in metrology or for applications with different wavelengths, for example, in the ultraviolet regime. I hope that the long-term effect will be mainly due to that we're inspiring other researchers and that it will be beneficial for the whole ecosystem. Doing a PhD in any field will be both a highly challenging and highly rewarding time. You will learn a lot, you will work a lot, and after your PhD, you'll be a different person. It's a huge endeavor, scientifically and personally, so choose wisely.